Hello there, and welcome to the NeuVector egress control in Kubernetes webinar. Thank you, everyone, for attending today. Going to get started real quick and talk a little bit about egress control. Now, let's get started. The reason I've chosen to talk about egress control is it's one use case in lots of different security layers. And when we think about security layers and we think about how things can become vulnerable in an environment, in environments that I've been in, we always kind of assumed we were always compromised. We always had kind of we can never assume that we're not compromised. We were constantly looking in multiple environments that I've been in. And the way that these things kind of get in, vulnerabilities obviously can come in through packages, applications that you're deploying, libraries that you're using in those applications, things like that. Misconfigurations, having the wrong settings or using default settings is always a prime candidate or culprit in misconfigurations. This is why we compare configurations against things like CIS benchmarks. One of the bigger security issues that I've always experienced and that I see in a lot of environments is sometimes you are opposed to the velocity of software development, right? The purpose of developing custom applications to gain business advantage, these kind of things. You want to be working as a software development organization. I have always said, if you have software development in a company, you're a software company. You're no longer an automobile company or financial services company. No, now you are a software company in that business. And so you need to develop software with velocity. It needs to have business value to go to the expense and trouble of doing such a risky endeavor. So if security is slowing that down, that is a problem. Now we're having to make trade-offs for velocity and security, and you really don't want to do that. In Kubernetes, we now have all these new attack surfaces, right? This is still a relatively new platform for running containers, running things in the cloud. It's supposed to help us orchestrate and do health checks and those kind of things. But it also creates a new attack surface, right? Inside of Kubernetes, being able to see what's going on, see any kind of container escapes, things that are happening within the applications themselves. And especially if we're thinking about egress control, we're really thinking about all of those things that are leaving that environment, right? The egress I have always thought of as the back door, right? If someone somehow gets in through a window, they're trying to take something, they're trying to leave out the back door with that thing, right? It's no value unless they can take it and go with it or share it, distribute it, and things like that. So I've always kind of thought of it as the last hope for stopping something that shouldn't happen or shouldn't leave your environment. If you can if all the other gates fail, all the other security layers fail, egress becomes the last thing before it's gone and out of the environment. So good use case for us to kind of explore and look at when we're talking specifically about things like egress control. How can we compare these things? Different ways of doing egress control, whether you're doing it with just the native Kubernetes network security policies, or if you're using something like Istio in a service mesh, if you are using maybe an orchestrator like OpenShift based on Kubernetes, but Red Hat has brought a lot of other capabilities along with Kubernetes and built that on top of that, and commercial products like NeuVector. I'm forced to show that too. So quickly and full caveat, and please use the chat if you'd like, if there are any questions. If I say something that's wrong, please correct me in the chat. I do not claim to be an expert in everything Kubernetes egress because I frankly have not worked in an ops environment. People who have worked in operations or who have been maintaining production Kubernetes environments and have used Istio, I can relate a lot of the stories that I have been told and things that I have seen in those environments. But having worked in ops, I know there's nuances and details in those environments. And so So I'm going to share the things that I know, and hopefully these are things that you can continue to look at. I'll share a couple of the references of where I got some of this information as well. So if you have stories or you want to share or ask questions, please do so through the chat. I think hopefully we all kind of understand what egress control is. We're talking about connections that are going outside of the cluster. And for today's purpose, we're going to basically anything that goes outside of the cluster. There's some terminology around outside of a namespace or things like that. I want to kind of keep that simple. OpenShift defines this as outside of the project. But the reason, this is why we're going to talk about it. Limited potential breaches and attacks. So these are some examples of the kind of things that we're trying to prevent. Data breaches is the easy one, right? That's if your data ends up leaving, it's, someone takes that package and runs with it. That's obvious. Connections to command and control and reverse shells, that also is a big one. So whenever we see attacks or we talk to customers that have been attacked, it's usually trying to get into the environments and people poking around. They found an exploit. They've been able to get some kind of response. Maybe it's an HTML response. And that gives them hope that, I've been able to execute a command in this environment. Let's see what else I can do. And trying to get reverse shells to where they can then begin to explore and dig deeper and maybe find something of value that they can take. Crypto mining also a great use case for egress control. The challenges for egress control are run parallel with the challenges of Kubernetes networking entirely. The source IPs of pods can and do change. In fact, we have even seen where IPs are being reused, where you're in a cloud environment and they're cycling through IP addresses within a particular range. And then, so the same IP address comes up 2 months from now. So those things can change. And sometimes when they can also be reused and it wasn't even for the same pod. So that can occur. Container gateways inside a cluster can be a bottleneck and can also obscure the source. This has more to do, I think, with the Istio. I'll talk a little bit more about this, but that obscuring the source can be a problem, not to mention the performance around a bottleneck. So let's dig a little bit into we're going to start with Kubernetes. If you're running in Kubernetes, it's free, right? You can do this without paying anybody any money. So this is a good place to start. If you have nothing else, please use some egress control, use some Kubernetes network security policies. Requirements, they do need to be supported by the CNI. Another requirement, you do have to use at least one network policy. That kicks it into gear. That causes it to be used, because if you don't use a network policy or at least one, it is going to work. Default namespaces, and the default, everything is allowed. Best practice tip, don't deploy anything into the default namespace. I have seen the namespace used in ways that was detrimental to the environment, production environments where maybe multiple environments were in the same cluster, and so namespace was being used to define, well, this is the prod namespace and this is the dev namespace. That actually can cause problems also. You're really doing segmentation with a namespace, so use it to identify the applications within the environment and don't deploy anything into default. That will make things a lot easier. A lot of vendor tools are kind of built on the proper use of namespace. It'll just make life much, much easier for you. But I digress. Kubernetes egress control, it does support IP and ports. So this is layer 3 and layer 4. You can do egress from a namespace. That's kind of, so the example that you're seeing here, you're seeing egress here being allowed to this CIDR block of, /16 block right there. So that would be an example of an egress control right there. Notice that this is only an allow rule. So the limitations, and I'm going to click through until I get to all of these. And I hate to say limitations, but these are kind of the things you may have to grapple with. I don't I didn't want I don't want this webinar to be like, well, here's 3 bad ways of doing it, and there's our way, right? I want to all ways of doing any way of doing security that improves your security is a good thing. Do security, please. No matter which product you decide to do some practices there. So deny rules. So there was talk, I think, in version 1.20 of Kubernetes that they were going to start supporting allow rules. I think that got pushed out a little bit. So still, as of today, there's only only allow rules, I should say. There are no like deny specifically to this IP block or things like that. No concept of external outside of the cluster. You have to specifically allow connections to go outside of the namespace, but then you have to do it separately for specific services. There's no rule prioritization or order. So if you're used to firewall rules, you're used to seeing that you can put them in certain order. And if you hit a rule, that's the rule that takes place. And then at the very bottom of that long list is, and a deny all. If we don't match on any of these rules, deny all of that traffic. You don't get that just using the Kubernetes network security policies. No host name, DNS support. This is a pain, especially when you are trying to maybe prevent certain DNS names, any egress to certain DNS names. That can be a pain because those DNS IP addresses do change underneath those DNSs. Policies applied to all namespaces and pods is a limitation, and the ability that you can't apply, I should say, you cannot apply policies to all namespaces or pod. They have to be specific. And generally, these are created at dev time. So this is part of, usually you have developers or you have someone who is creating these policies by hand in YAML files to engage these. And then these are basically saying, these are the paths that have been defined for my application or my service. Hard to read down here, but these all came from the Kubernetes docs and their network policies. And these are all listed in what you can't do with network policies, at least not yet. Quick pause. Any questions or anything around Kubernetes egress control? I see nothing in the chat. I will keep checking the chat periodically. So feel free to throw things in there. So this is the basic. This is kind of where we will start from. Let's talk a little bit now about OpenShift egress control. And you'll notice here, this is going to look a little bit different. So notice this API over here, the metadata. So this isn't kind of egress network policy. This is a custom resource definition that OpenShift has employed. So this is how this is done. Custom resource definitions are a way to extend the Kubernetes API so that you can do, vendors can do other things. A little bit of vendor lock-in if you use CRDs. Pros and cons to that, obviously. The egress network policy is able to deploy an egress firewall. And so this does have the concept of egress outside of the cluster. It supports one egress network policy per namespace, but it is not allowed for the default namespace. So all of your rules are going to need to be put in a specific namespace policy. I like that. I don't even see that as a negative because you shouldn't be using the default namespace. Just causes issues. Does support the resolution of DNS names. And there is a concept of rule ordering, a little bit limited in the fact that the order has to appear as you're seeing in this example right here. So when the different rules are shown, that's the order that they're going to be hit. And so as we're showing for this specific namespace, for this demo namespace, it would support all of these rules here, and also does support deny rules. So you'll notice that deny rule to Yahoo and that site are right there. A few notes on egress control with Red Hat. So OpenShift. This will not apply to routes. So if you're using routes to send traffic from the namespace through the pod to the router, then the egress controls are not going to apply to those routes. Secondly, the egress controls that you see here are applying to a namespace, so you can select a namespace from which egresses are allowed. Unlike Kubernetes, which there are no pod selectors in that. In Kubernetes, you can do namespace and pod selectors, but in OpenShift, you can do namespace without pod selectors. So that's kind of a more flexibility there. No protocol verification. So in both Kubernetes and OpenShift, there is not an ability to verify the app protocol at layer 7 for egress. And that's another layer of security that can prevent tunneling or other types of attacks. So the ability to identify a protocol is kind of one capability, then to also validate that protocol, to not only be able to identify it, but to verify that the traffic that's within that protocol, the payload, is not obfuscating some kind of tunneling attacks, SQL injection, struts, trying to remote code execution, RCEs, any of that kind of thing. If we can see in the network traffic, if we can validate the traffic is valid for that application protocol, that also means we can validate when it's not, and we can detect tunneling attacks, etc. So they have OpenShift, Red Hat, or OpenShift and Kubernetes cannot do that. There is, and as you saw in the rule management capabilities, the rule does have to be set in the YAML file. This usually does have to be created by hand by someone, usually in development. So depending on how much you're going to use in this case, the egress network security policy or any of the security policies in Kubernetes or OpenShift, you're going to have to spend some time making sure these are accurate and right and in place and can be tested on those. Istio, so very popular service mesh. Why are we using a service mesh? I'm not even going to talk about what it is. It's basically a network overlay, right? Istio and service meshes typically use sidecars. Sidecars are usually associated with a container. So every container within the cluster has a sidecar. And then Istio is managing this sidecar service mesh, network mesh overlay. So it's kind of its own network on top of the Kubernetes network. And then all of the traffic is flowing between the sidecars because Istio can control those. So choosing sidecar proxies, using that overlay network to do all of their traffic policies. And you can see here's an example of the Istio service entry. And here I think we're looking at Google. So we have created a service entry basically for Google and this egress control. Let's see. I've got a couple of notes here. In Istio, the egress is allowed through, well, let's see. You can see this outbound. This is an outbound by default. It's going to allow all egress so that you can also set it to a registry only or for specific protocols or host destinations. Let's see here. So we can allow a bypass for the Istio proxy for a specific IP range. So if you want to go to an IP address directly and not go through the proxy, you can configure that egress to work that way as well. You can also implement egress control via an egress gateway, which will allow you to do external HTTP and HTTPS services from applications inside the mesh. A specific use case that I found for this approach might be a cluster where the application nodes don't have public IP addresses. So the in-mesh services that run on them cannot access the internet. Defining an egress gateway, directing all of that egress traffic through that, and then allocating public IPs to that egress gateway node allows for the application nodes to access external services in a controlled way. So egress gateways. Details of interest. Sidecar proxy is not considered secure and can be bypassed. So this is also from the Istio documentation. And basically, what I've heard from customers, and also things that I've read from operational experiences of those that blog about it and different things like that. So this in particular, how do I say that? Istio is really good with HTTP and HTTPS, right? As far as protocol detection. Other protocols, not so much. The reliability around non-HTTP protocols drops significantly. And I've seen environments where they're only using the service mesh for those protocols. Also, the fact that this sidecar proxy is not considered secure, so Istio can only really guarantee that the routes or the protocols that they have specified must flow through those sidecar proxies. So there may be a way to not use the sidecar proxy, which means you would immediately drop out of maybe some of the telemetry that Istio collects around the network security. And since I mentioned that telemetry, shout out to Istio marketing. They've splattered telemetry everywhere. It's like, well, you need telemetry. You need nice use of telemetry, because you got to have telemetry if you're going to do security, right? No application protocol verification for So again, not reliable application protocol verification. They can identify a few, and they're really good with reliable for HTTP and HTTPS. Maybe not so much with others. In fact, I was even researching a little bit because I was looking at some TLS and how the TLS works between the sidecars. Was involved in a discussion where we were talking with a group that felt that the TLS was extremely important, and it's another security layer, but it is still TLS between the sidecars. So what Istio is doing is the overlay network is encrypted, and that's the network that all the services are going to use. This is how Istio collects all that telemetry, et cetera. But it doesn't mean that you're going to be using any TLS for anything else. If you're able to do other activities, or you're able to escape that through that and not use that sidecar proxy, you may not be getting TLS. But everybody says, well, I have TLS between my applications. Technically specific, you have TLS between the sidecars of your applications. So again, we're kind of relying on Istio to make sure that everything is covered there and that you're getting all the benefits of using TLS. Mentioning this egress gateway, that's Istio cannot securely enforce all that flows through an egress gateway. So you would have to add to that either some Kubernetes network security policies or some other alternative solution to kind of build the security walls to make sure that everything flows through that egress gateway. This also can create a little bit of a performance issue. And we have seen this with different service meshes. I know from firsthand experience doing big testing on like 1,000 node clusters. So a single cluster with 500 nodes, 750 nodes, 1,000 nodes, really big clusters. The performance when using sidecars is not going to maybe reach quite as deep as you may want to go there. Those gateways, especially when you have thousands of pods coming and going in these massive environments, that performance can be a concern there. So we've covered now Kubernetes. We've talked about OpenShift. We talked about Egress or Istio, and these are just kind of the nuances between these different approaches. What would advanced egress control come from? And this is kind of a highlight of the things that, say, a commercial product like NeuVector would bring to egress control. So I'll just kind of click through these. Multi-protocol, so being able to do more than just HTTP, HTTPS, and DNS to be able to do lots of different protocols like application protocols. Being able to use IP site ranges or host names. Layer 7 verification, so being able to identify app protocols and verify those protocols. Possibly even extending that to deep packet inspection with payload inspection. So this would pertain to things like data loss prevention, being able to see on the egress, inspect that payload, look for things in that payload like credit card numbers, social security numbers, any kind of sensitive information that you don't want leaving to be able to look at that payload on the egress, inspect that payload, and make sure that there's nothing in the payload that you didn't want escaping your environment. So that would be really nice for egress. The flexibility for either monitor or protect. So like with a lot of firewalls, you can even have you don't want to block everything, but you want to know about it. You want to get alerts. You want actionable data. And so having some flexibility about the control on that egress, maybe you're not blocking everything, but you want to be aware if some network traffic were to pop up there. Full logging, alerting, packet captures, so more visibility into what's actually going on within the environment from a networking standpoint, ability to do packet capture inside that environment. That would be really nice. That's a great forensic when you see anomalous activity to be able to do some detail on that. And more flexible rule management, being able to apply rules to multiple clusters, apply it to an entire cluster. And of course, being able to use APIs and automating some of this stuff so that you don't have to create these rules by hand. So I think all of these bullets are covered by NeuVector. So let's talk a little bit about the NeuVector commercial approach to egress control. You can do this based on IP or DNS name. So that's a huge win right there. I'll demonstrate this just a little bit in NeuVector. Application protocol, identification of an application protocol and verification of that protocol. So that would be that's a big deal in NeuVector, that we can both identify layer 7 as well as verify that, looking for tunneling attacks. Typically, those attacks are coming on the ingress. So being able to use that application protocol gives you another layer of security to say, well, if it doesn't match the protocol that I wanted or have seen before, that's a concern. Multi-protocol, I think we support 35 different application and network protocols, and more granular rules. So we can actually build rules based on a service. We can do it based on the deployment name. We can use labels. We can even use custom groups. So you can create a custom group. That's what I'm going to show you. Make a custom group and then do rules based on that. So maybe a custom group that's using a DNS name for that egress security there. And the DPI, DLP, extend that egress control to do deep packet inspection of all that egress traffic, do data loss prevention to be able to see that. So here's a couple of pretty simple examples of egress controls in NeuVector. What these diagrams are showing is basically that if you had IP addresses that you could block or use DNS names. So even though those change, make Morningstar an allow rule and make Oracle.com a deny rule. I didn't make that up. I'm a former Oracle employee. I would have put a much stronger block on that. I kid. Example 2, all traffic must go through a SQUID proxy. So this is very common. So maybe you want to block access to certain domains and allow access to certain domains. So this also would be supported in NeuVector. Again, one of the big pain points in for egress control, any kind of network security policy, is the fact that you have to create them. You have to have somebody responsible for creating the YAML file and creating those egress rules, and then they get verified, et cetera. Most of the time, especially if it's kind of a DevOps culture where there's, shift all the work left to the developers, they love that. That does come in. That's one of those things. If you can define it early, if you can make that security as code, define those definitions and make those part of your CI/CD pipeline, that's fantastic. If you have to rely on ops to kind of come in after the fact and look at traffic and create those rules, probably a little less optimal from that standpoint. What would be really awesome is if you could just automate the whole thing, right? If you can see the network, automate the rules for the network, use those rules, they should be very exact and those kind of things. Well, it just turns out that's exactly how NeuVector does this. When you apply the NeuVector security platform to a cluster, takes about 10 minutes to do that, and you apply the license, we immediately are in discover mode. We're immediately learning all of the network traffic natively. So we can do this at layer 7. We identify the layer 7 protocol, we validate that protocol, we see all of the traffic, pod to pod, container to container, namespace to namespace, et cetera, all the egresses, all the ingresses, and we learn that behavior. Then with a click of a button, we can move to monitor mode, which turns off the learning and turns on basically zero trust segmentation, right? We've learned your behavior. We do this both at a network and process level. So it's not just the network egress, we can do it at process as well. And then this zero trust segmentation is based on that behavior. So it's automated. We can build the rules automatically, and then we can alert you. So anytime we see something that wasn't your behavior, you'll get alerts on that. That's what we want. We want to reduce the size of the haystack where the needle is, so that if we have a few pieces of straw left, there's the needle. We want to be able to reduce known versus unknown behavior. And just a quick mention on zero trust. It's unfortunate what marketing and vendors have done to zero trust. It's not a product, it's a philosophy. It's an approach to all of your security layers, the known versus unknown. RBAC is zero trust. I know who you are, you've got a login. I don't know who you are, you don't have a login, right? So it's a thing across lots of security layers. Zero trust segmentation at a network level has been around forever. It's not a product, you can do this, you can apply that approach using these behaviors. Now, not only can we alert on these things, if we, like I mentioned earlier, we have that monitor versus protect mode flexibility. So yeah, if you want to block that anomalous activity as well, you can move to a protect mode, which will still use those exact same rules, except now we will block that process, we'll block that unknown network connection, that unknown network egress, and we'll prevent those from happening automatically based on the behavior that we learned. Because we use the network as our source of truth, NeuVector's one giant claim to fame, unique capability is we use the network traffic as our source of truth. We're not using Kubernetes IP tables. We're not having to do eBPF. We're not using kernel shims and trying to filter out all of the send and receive commands that are happening at the kernel level on the host. That's what eBPF does. Great tracing technology, performance, learning everything that your application is doing. But if you're going to apply security at a kernel level, that's a little late. You'd like to have some security layers in front of that, network layers, process layers, before things hit the kernel and are run by the kernel. eBPF is designed specifically to not block anything, right? If you're messing with the kernel, you don't want to take the kernel down, right? Everything goes down at that point. So you got to be careful with it, but at the same time, you're missing some layers that you can take advantage of by using Kubernetes network security policies, et cetera, et cetera. So any of these approaches that we've talked about here are an advantage for security at a network layer versus using kind of network process. That's the other thing they talk about. Well, we can see the network. No, they're seeing network processes at the kernel. The network traffic is not seen at that level. That's why they can't use the network as a source of truth. Oh, and this is the slide I hate, because now we're going to talk about actually doing this and showing how this kind of works. So I'm going to log into my cluster here. I have a container that's running in this cluster, and this container has process rules. So we have learned some process rules here. We have some network rules, and you can see we've learned this. So this is all done automatically. You can see the application layer here. We've got some MySQL and Redis, so can create those rules. You also notice over here on ports where it talks about any. Basically, if you can identify the application layer, you have a little bit more flexibility on ports. If the ports are changing, that's fine. We're verifying on that application layer and making sure that only that application protocol is being used. So that gives us even more flexibility of being both granular and having more flexibility at like layer 3, layer 4. If for some reason it's a custom app protocol or something like that, we will then collect that layer 3, layer 4 there. I got a question. What is the learning period for Discover mode? Can we customize 10 minutes to 24 hours? You know what? That is a great question. And I have a little bit of time here. Let me demonstrate how fast this can happen. So I've got a environment here. Forgive me for not having this thing up ahead of time. I've got an application here. This is a very simple super app order, and it's running in this cluster right here. And so let's go to this container. So this is the container. I've got it in a protect mode. So we've learned some rules. I've learned some process rules. I've learned some network rules here. And again, simple application. Everything is running in that single container. What I'm going to do is I'm going to delete all of these rules. This is everything that we had learned from a process standpoint. Make sure I delete that custom one there. So that's good. And then these network rules that we see here, I'm actually going to do this from the network rules page because, again, when we have these ordered with all of the network rules like a firewall, then we want to make sure that we can that's where they are. So this is why for these two rules, I'm just going to delete those so that we have no known behaviors. Say delete both of those. I'm off-road on the webinar plan, so but I'm going to show how quickly we can learn these things. So no network rules there for that container, and of course, and as I just mentioned, no process rules. So what I'm going to do is I'm going to move this into a Discover mode. We're going to learn the behavior all over again, and this is how we do that. You go to your app and you exercise that app. So let's make another one for Young, and we're going to give Young some stuff. We're going to submit that, right? And then I'm going to delete this one. And let's view Jim here. Yep, we can see Jim. Let's go back to orders. So I've done things here. I've created, I've edited, I've deleted, I have exercised the application. This could include running reports. This exercise the application, click on all this stuff, make sure all the services are called, all of that kind of thing. If you can do that in 5 minutes, we will learn that in 5 minutes. As I hit refresh, you'll see, yeah, we're running a Java application. That's the only thing we're doing. That's all that's happening. This pause, that's actually a Kubernetes native process that Kubernetes runs as it's checking in on these containers. So I have now learned the process. Let's go over here to the network rules, and I've got network traffic there. So we're allowing that HTTP traffic to go from the nodes to the struts, et cetera, as I'm using that. Let's move this thing now to monitor mode. Or you know what? I'll just go ahead and move it to protect mode. Oh, sorry, I was on the wrong thing. So now I am blocking anything that is not learned, anything outside of this. If I tried to bash into this container, if I try to do anything outside of these processes, it's going to get blocked. So if I come back here, try to create a new order, submit, everything still works. We're seeing the exact same processes. We're seeing the exact same behaviors that are learned there. So that's kind of how that works. Another question, does NeuVector deploy inside cluster as a particular namespace with privileges? Yes, we typically deploy NeuVector in the NeuVector namespace. It includes 4 containers. One of those containers is deployed as a daemon set. So the enforcer is deployed as a daemon set. That's how we're able to inspect that traffic. And that will, oh, thank you, Young. So that is, I totally lost my space. Yes, we deploy the enforcer as a daemon set. There's 1 enforcer per worker node. So if you have a 10 node cluster, you'll have 10 enforcers. These are not agents. They don't communicate directly with the Kubernetes API. Our controller container is the only container. There's usually 3 of those running. That is what runs, or that's what communicates with that Kubernetes API. So no code changes, no sidecar overlays, no agents, works, very easy to deploy, very easy to remove as well. Since we're talking egress, I'm going to do a very quick demo on the egress. So I just kind of went off-road on how we do the behavior learning. But what I really want to show you is some egress control. So I've got another container here, this exploit demo container. Same story, learned some processes here, have learned some network rules here as well. And I'm in a monitor mode. And I think what I'm going to do is I'm going to create a new network rule, and I'm going to limit my egress from this container to say, let's say Google. In fact, let's make sure, I don't think I do right there. So here is a custom group. And if I look at this custom group, you'll see that the address that I've used here is star.google.com. So I've made a custom group. Custom groups is kind of like a secret superpower. We never talk about it like on sales calls and things like that. Nobody's really like, hey, we've got custom groups. Want to buy that? No. But this is kind of the superpower that makes so many things possible and easy to manage with NeuVector, being able to do these custom groups because we can take these and apply them to other clusters. So very simply, I've got a group named Google. That's the address. I'm going to use that to create a network rule. Now, before I do this, I happen to be in that container, and I have bashed into that container. So I am now inside of this container that we were talking about, this exploit container. And I think, let's see if I have a curl command. There we go. Curl www.google.com. Yay, got a response. So if I curl Google, I'm getting a response. I would really rather not allow that container to make curl commands out to Google or wherever it is. So let's add a network rule to the top of this. And there we go. I'm going to do this from my exploit container. So there's that container group. You notice here, sometimes I get a question on, well, what's that NV in front of that? So NeuVector will identify if you have multiple pods running the same image, and we will automatically group those together so you can apply rules to all of that same image, right? If you're scaling up to 100 pods to handle a particular service, you want the same rules being applied to all of those. So that's why we do the custom groups to make that easy. And then two, if I start typing Google, there's that custom group that I made. So I can use that, and I'm going to make that a deny rule. And I think we're going to be on any. So we'll just do any. I'm just going to leave that open. Right there. Let's save that. And that policy has now been deployed. Let's go back here and clear that screen. And let's curl Google again. All right, we got a response. Well, what's up, Tracy? Thought you said you were going to block that. We got a deny rule. But let's go back to groups real quick. Go back to our monitor here. So here's that demo. It's in monitor mode, right? So if I go to my notification security events, I'm probably going to have a security event saying, hey, we weren't going to allow that, right? So there's that network 31 was violated, right? I can review that rule right here. Yeah, I was saying, no, we are not allowing that traffic to go from there, but we're in a monitor mode, right? So if I want to enforce this, let's go back to our container and change the monitor on this particular container right there. So instead of monitor, let's move to protect mode, because that's supposed to alert and block, right? So if I've done the magic trick correctly, we're in monitor mode. Let's clear that. Oh, I'm in protect mode. I can't even run clear now. Well, let's try that curl command. Not getting a response, because if I go back to my notification security events, now there's my clear. And I'm one step behind here. In a moment, the notifications come a few seconds after the actual block happens. There we go. So you can see that rule 31 violated, and now we have a deny instead of the alert before. So we blocked that, that was happening. And there you can even see my clear command got blocked because that was a process rule. So we block at the network level, we block at the process level. And then the super cool thing about that, so let's go one more time to the exploit container. So my process rules here, if I were to add clear, that would happen there. You know, I'm gonna remove this bash because I'll show you one more little quick demo on that. My curl is there. I'm also going to remove this shell because I don't want anybody doing any more demos on this like that just did. And then we get those network rules, right? So there's my deny rule, etc. I can take these rules and I can export them in a different mode. I can keep it in monitor in protect, or I can move it to monitor. This is why the developers love this, because unlike those other examples that I was giving earlier, we can build that YAML file for you. So you don't have to have somebody manually create this. So you can do this based on the behavior, right? That has all of my behavior for that one container, all of my actions that I just allowed or disallowed. I could change this, put this in version control, et cetera, et cetera. So that's a little bit of security as code. So again, if you're using a commercial tool, this should save you some time and also give your developers or whoever is having to create those network security policies, give them a break. Now you can just verify that this is everything you want based on that behavior that you learned. So I've shown that. I think that now that I'm in protect and I changed my process, I can't do that bash anymore. Let's Control C. We're still blocking Google, so we won't try that anymore. I can't do other things there. What if I exit and try to go right back into that container? I can't get back into that container because, again, we're in protect mode and I took away the ability to do bash. And so that operation is not permitted any longer. Any other questions, comments, anything anybody would like to ask about as far as security rules, network security rules, or any other questions about NeuVector? Happy to take those now. I see we have about 10 minutes left. Thank you, everybody who is paying attention and moving along with us. The license model for the product is based on nodes. So, for example, if I go to my assets nodes here, there's one failed. So this is a 5-node cluster. And so we price based on nodes. We do price production versus non-production a little bit different, but basically based on nodes. Would you still recommend using Istio if you have implemented your tooling? Yeah, absolutely. The biggest complaint that I hear about Istio is operational complexity. Things like, for example, if you're using init containers or if you're using cron containers, like you're spinning up something to do a cron job in Kubernetes, when Istio spins up a sidecar, it won't, for those types of, if you're going to do an init container, or you're going to do some kind of cron container that just spins up, runs the cron and disappears, you're going to have sidecars that will not exit. They're not going to leave. So sometimes there's some issues around that. What I have seen the most is really kind of using it for HTTP, HTTPS traffic, and egress gateways for that. MTLS, yes, that's no reason why maybe not to use that. Our product works 100% with Istio. And so we see the sidecars, we see the traffic. We don't see the encrypted traffic, but we do see the traffic before it gets encrypted by the proxy, as well as when it gets decrypted by the the receiving proxy, and so then that traffic is usually in plain text between the proxy and its sidecar. So we're still able to see everything and do all of that. What is my opinion on Linkerd versus Istio? I have seen people going to Linkerd from Istio. We have a lot of customers that use Istio. It's like I said, it's a very, using a service mesh also can reduce some of the complexity and let that handle that complexity. I do hear, when we ask about, well, are you using everything in Istio, or are you just kind of using MTLS and maybe the egress gateways and things like that? I do tend to see environments using simpler capabilities and not necessarily going to some of the corner cases. I feel like they use different things to address certain use cases, but mainly those two. And like I said, some of the blogs that I've read of kind of firsthand operational experience, which I do not have, but firsthand operational experience of folks that are saying, yeah, I was using Istio for a couple of years, now moving to Linkerd. Every environment is different. So I would say, test them out and see which one delivers the things that you want without the operational overhead and pains that might come with that. Got another question from Ron. Can your product work alongside other overlay tools such as NSXT, which can extend into Kubernetes? I'm not 100% on NSXT, but I can tell you basically because of the architecture of NeuVector, because we're container based, we run inside of Kubernetes, we plug into things natively like admission control and stuff like that. But because we are independent, we're not necessarily relying on our own overlay network. We're enforcing using our own capabilities within the cluster itself. We communicate to the Kubernetes API, but we're not a skin on Kubernetes. We're not, creating layer 3, layer 4 network security rules. If you already have rules and you've committed a lot of time to that, use NeuVector as the analogy I like to use is you've locked all the doors on the data center. Now you're going to put in security cameras over the doors. Why do we need those? We lock the doors. I'm using network security policies. Well, the camera is to verify that you locked the door. If you miss something, NeuVector would be able to pick up on that traffic and identify, hey, we haven't seen that before. So you can use it to verify that your network security policies are working in place. So Ron, my knee-jerk reaction to that question is probably we would work fine with it. Again, we work fine with Istio, Linkerd. We work on all the clouds. We're basically CNI agnostic because, again, we are working inside of Kubernetes and can see all of that network activity happening there. So Azure, EKS, GKE, IKS, IBM, EI, EIO, right? Any other questions? I see we're coming up on time.
Tracy, did you see the questions in the Q&A box?
Oh, I did not. Thank you. It feels like this would be tough to run at scale. Can you comment at that? I would make 2 comments on that. And I may take the second one as well. Maybe I missed it, but why can't we accomplish this level of security by just being good at IP table rules, et cetera, in the CNI? Well, if you're good at IP table rules, that's great. I think that's a lot of overhead right there. We don't use the IP tables. And sometimes I think there's even some confusion about how we are able to do the things we do without using the IP tables. Again, we are using the network as our source of truth. So we see the network traffic itself. That's how we're able to identify the layer 7 protocol independently of what's happening at Kubernetes. And anytime I get questions about, wow, this seems like a whole lot. Whenever we do POCs, typically we will deploy the application and then you're immediately getting this activity. Now, albeit very, very small environment, you've probably got lots of nodes and containers, and it's going to have lots of lines and things like that. But it does make it very easy that when we're learning all these rules, that's all automatic, right? And then when you want to establish basically a policy of implementing zero trust and all of that, now, yeah, you see federated rules because we can share rules across clusters and all of that kind of thing. But at a very, very simple level, I could select every container that's running in this namespace and move the entire thing to monitor mode. And I won't affect anything. It's completely safe because we're not going to block anything. The performance seems like it would be tough to run at scale. We've scaled up to 1,000 nodes in a single cluster. This testing was not done by us. This was done by a hyperscale cloud provider. There's only 4. I can't mention which one it is. So you got a 25% chance of getting that answer right. There will be press releases coming. But anyway, yeah, we've been tested head to head against other products and came out on top of those pretty intense performance testing. Not everybody can get their hands on a 1,000 node cluster. And so, yeah, that kind of testing, our architecture allows us to scale like that. Sidecar approaches, agent approaches don't necessarily scale at that level. And because we're automating so much of this, the management of this can really be as little as you want or as much as you want. We have customers that run 100% in monitor mode that are in a security group that has no influence in development, right? Nobody wants to be slowed down, but they're charged with improving security, but don't make us do anything about it, right? So those security groups, they will run in monitor mode. They can see things. They can ask questions about things. They can see what the abnormal behavior would be or anomalous behavior that they haven't seen before. So that gives them a way of doing that without having to impact or slow down anything in production. Then we have other customers that run in air-gapped environments, high security, that are watching this every day. So as little or as much as you want, the benefit is you're getting this information. We're taking a giant haystack with one needle maybe in it. You should always assume there's a needle in the haystack. You should always assume that you're compromised. You should always be looking for ways to identify what those compromises could be. It's not all about just patching vulnerabilities. You're not secure if that's all you're doing. There are vulnerabilities in every production environment right now that do have exploits that just haven't been identified or published yet. And you have to always assume that stands from a security standpoint. Always assume you're compromised. Always have a way to identify if you are. Keep your focus there. Yeah, scan. We have scanning. Everybody should be doing scanning. But that's how I would say, tough to run at scale. From a architecture standpoint, not a problem. From a operational overhead, not a problem. We can flex with just however much you want to put into your security. With 30 seconds to go, thank you so much for attending and spending time with us today. Really appreciate it. Hope this was beneficial. Any follow-up questions, feel free to reach out to us anytime. We're always listening. Thanks, everybody, for attending.